Hello everyone, this is Dr. Lennon. This is the final exam review. So let's take a look at the first problem. It's just a ratio problem. So it says a 12-foot I-beam weighs 264 pounds. How much would you expect a 15-foot I-beam to weigh? So if we write out a ratio, we know 12 corresponds to a weight of 264, and we would want to know what is the corresponding weight of something that is 15 feet long. So you can just cross multiply here. So we would do 12 times x, and that would equal 15 times 264. And you can multiply that out if you want, but I'm just going to leave it alone because we're also going to divide by 12, and then I'll just do that all in my calculator at once. So x is going to be 15 times 264 over 12. And that comes out to 330 pounds. So the ratio was pretty simple to solve. We just need to make sure the corresponding units are in the corresponding parts of the fraction. Meaning 12 feet was on top on the left, so 15 feet was on top on the right. 264 represents pounds, so when we solve for x, that will also be in pounds. Okay, so for number 2, we just have a percentage word problem. So it says 80% of what number is 15? So we want to remember our key translations when we go from words to equations. So 80% as a decimal, we move the decimal place 2 spots. So as a number, 80% is 0.8. Of is always going to translate into multiplication, so we're going to do 0.8 times. When you have a question word, that's usually an indication that you want to put a variable there. So if we do 0.8 times x, will translate to equals. So that equals 15. So you could write it down also without all the parentheses. It's just 0.8x equals 15. And then we can solve that, and that will give us the answer to our question. So x, if you put that in your calculator, will end up being 18.75. So 80% of 18.75 is equal to 15. So the third question is just solving a linear equation in one variable. So basically what we do is we just want to pick one side to put x on and then put all the numbers that don't have an x on the other side. So I like to keep my coefficient of x positive. So what I'll do is I'll add 4x to both sides here. So if I do plus 4x to both sides of my equation, the negative 4x and the positive 4x will cancel. So on the left-hand side, I'll only be left with the 8. And then on the right-hand side, 12x plus 4x is 16x minus 5. So then to move the 5 to the left-hand side, we just do plus 5. So we do plus 5, and we have 13 is equal to 16x. And then on both sides, we'll divide by 16. So 13 over 16 is your answer. So that's all there is to it. Just pick a side for x, pick the other side for regular numbers, and then you want to move those via addition and subtraction until the x is on its own on one side. Then once that happens, we divide by whatever its coefficient is, and that gives us our solution. So for problem number 4, we've got something similar, but now we've got a set of parentheses. So to remove the parentheses, especially when you have a variable trapped on the inside, you want to use the distributive law. So here we just want to multiply 5 by each term in the parentheses to remove it. So 5 times 3 is 15, and 5 times minus 2x is minus 10x. And then it just reverts to the previous type question. So again, for this one, I want to move my x's to the right, so I'm just going to add 10x. So I have 15 is equal to 29x plus 1. And then what I want to do is just subtract 1 and divide by that 29. So I subtract 1. So I have 14 is equal to 29x. And I divide by 29, and that is my answer. So x is 14 over 29. Okay, so for 5, we have a word problem. We have a 132-inch pipe that's cut into 2 pieces, and one of the pieces is twice as long as the other. So if you let x be the length of the shorter piece, then the longer piece is going to have be twice as long, so 2x would be the longer piece. And then basically if you add those together, x plus 2x, you get the 132-inch length of the entire pipe. So from there, what you can do is x plus 2x is going to add up to 3x. That equals 132, so we can just divide by 3. And we get x is equal to, I think that's going to be 44 inches. So they actually asked for the length of each pipe, so we're not quite done. We also have to say the longer piece is going to be 88 inches. So that's the shorter piece, and then 2x, the longer piece, will be 88 inches. So that's that. Okay, so for number 6, we have to solve a system of equations. So remember, this is typically just where two lines meet. So there are two kind of trivial possibilities, or ones that don't come up quite as often. They could represent parallel lines where your system would have no solutions, or the same line where any point on the equation would represent a solution. So we say that would have infinitely many solutions. But this example and most of the examples you encounter, they just cross and meet at a single point. So our ordered pair will actually have an x and a y. So the way I like to go about solving this is with the elimination method. So you pick a letter and you try to eliminate it by adding the equations. So if you added the equations, nothing would go away. So you have to pick a letter. Let's pick x. So we want to get a common multiple of x where the signs differ, so that when you add them together, you'll get 0. So we can do this by multiplying the top equation by 3 and the bottom equation by 2. When you do that, you'll end up with positive 6x on top and negative 6x on bottom. But the trick is you have to multiply each term in the equation by those numbers. So the top equation becomes 6x plus 15y equals 36, and the bottom will become minus 6x minus 8y equals 20. So when you add them together, the x's go away, and you end up with 7y equals 56. So then you can solve for y by just dividing by 7. So we end up with our answer, y equals 8. Now we're not quite done because we have to solve for x as well. So you want to plug that into one of the original equations. Let's say the first one. So 2x will equal 2x plus 5 times the y value we just solved for, 8, should equal 12. So we end up with 2x plus 40 equals 12. So we can subtract 40 from both sides, and we end up with 2x equals negative 28. And when we solve that, we have, we just divide by 2 on both sides, and we get our x value, which is negative 14. So the solution is the ordered pair negative 14, 8. And that's it for solving the system. So that's the elimination method. So for number 7, we have a quadratic equation that we want to solve. So the way we learn to do that in this class is just apply the quadratic formula. So let's remember what the quadratic formula says. It says the solutions to ax squared plus bx plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac, with everything being divided by 2 times a. So in this equation, we have to identify a, b, and c. So a is equal to 3, b is equal to 10, and c is equal to 1. So let's plug those things in and just simplify using the arithmetic. So x should be negative 10 plus or minus the square root of 10 squared minus 4 times 3 times 1 divided by 2 times 3. So simplifying things according to order of operations up there, we have negative 10 plus or minus the square root of 100 minus 12, which is 88, divided by 6. So you can just leave the solution set as is if you want to identify both numbers, negative 10 minus the square root of 88 over 6 and negative 10 plus the square root of 88 over 6. This is not in simple radical form, but I don't think that they will ask for that. If they do, some things that can be reduced is basically, so simplify to simple radical form. Which is not necessary, but often you will see answers given in this fashion, so I'll go ahead and do it for you. So that negative 10 plus or minus the square root of 88 over 6 can be written as negative 10 over 6 plus or minus the square root of 88 over 6. So the first fraction can be simplified to negative 5 over 3. Oh, sorry, I'm just wanting to rewrite that a bit, negative 5 over 3. And then the second one, the square root of 88 is 8 times 11. So there's a 4 in there, so we can write this as 2 square root 22 over 6, which will simplify to negative 5 over 3 plus or minus the square root of 22 over 3. So they may leave it like that, or they may put it all together as one fraction, negative 5 plus or minus the square root of 22 over 3 as well. Again, this part is not necessary, but if you prefer to write things in simple radical form, that's how you'd go about doing that. Okay, number 8, we want to find the length of the missing side. So that to do that, we want to apply the Pythagorean theorem. So remember, the Pythagorean theorem says for a right triangle, the equation a squared plus b squared equals c squared is always satisfied, where c is the hypotenuse. So we know the hypotenuse is 25, so for us this will turn into 7 squared plus b squared. 7 squared, we're using the letter y for the missing side from the picture. So 7 squared plus y squared should equal 25 squared. So we end up with 49 plus y squared equals 625. So we want to subtract 49 from each side. So we'll be left with y squared equals 576. So you can take the square root of both sides, since everything is positive here, and we end up with y is equal to 24. That would be the value of the missing side in this problem. So just plug everything into the Pythagorean theorem since it's a right triangle, and make sure that your hypotenuse is the one all by itself, replacing c. Okay, so for 9, we want to find the lateral surface area and the volume of this cylinder. So let's remember those formulas. So the volume is just basically the area formula for a circle, pi r squared multiplied by the height of the cylinder. So pi r squared h is the volume. And the lateral surface area, basically, if you could imagine cutting the cylinder and unwrapping it, it would turn into a rectangle where the height is going to be one of the sides of the triangle, and then the base of that would actually be the circumference of the circle. So this would just be 2 pi r h. So we can plug our numbers into each one of those formulas. So the volume would be pi. The radius we see in that circle is 1, and the height is 20. So this will come out to 20 pi. And if we want to round that to, say, 2 decimal places, 20 pi is 62.83 about feet. So this is volume, so that's going to be feet cubed. 62.83 feet cubed would be the estimated volume. And if we do the lateral surface area, so I guess I should put LSA there for lateral surface area. Our lateral surface area will be 2 times pi times our radius of 1 times our height of 20. So this would come out to 40 pi. But since it's a surface area, this is only going to be in feet squared. So 40 pi would actually just be double our previous answer. But Let me just double check to make sure the decimals don't. So it would come out to 125.66. So 125.66, and that is going to be square feet. And that's it for problem number 9. So let's move on to the last. Okay, so for number 10, we just want to list the sine, cosine, and tangent of angle theta. So remember, for right triangle trigonometry, we have the acronym SOHCAHTOA, which tells us that the sine of some angle is, the ratio is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So for this triangle, 5 is, so let me, this is a right triangle. So 5 is the hypotenuse, and the legs are 3 and 4. Based on where theta is, the angle on the bottom right corner, 4 will be the opposite side, and 3 will be the adjacent side. So if we're doing sine of theta, it will be the opposite 4 divided by the hypotenuse 5. That's what the sine would be. The cosine of theta would be the adjacent 3 over the hypotenuse 5, and the tangent of theta, the third ratio in question, would be the opposite 4 divided by the adjacent 3. Okay, so that's it for question number 10. That's basically representative of what will be on our final, and good luck, and thanks for a nice semester.